We are then asked to calculate the time for the mass B to fall 1.4 meters. So B will start at this point and go down 1.4 meters. You should remember that the acceleration downwards is constant. This allows us to use the suvat equations because we have got constant acceleration. Unless the acceleration is constant, we can't use these equations. Let's see what values we should have for these variables. And remember that S is the displacement, U is the initial velocity, V is the final velocity, A is the acceleration, and T is the time taken. The displacement, since we are interested in the object going down 1.4 meters, is going to be 1.4. And at this point, we need to decide on a positive direction. It doesn't really matter whether you pick up or down as positive, as long as you stick to the direction that you pick. But I'm going to pick down as positive because the object is falling down and gravity is acting downwards. It's a bit more convenient. Which means I put this 1.4 as a positive value, not negative. Then let's look at the initial velocity. We were told that initially mass was at rest, so the initial velocity will be 0. The final velocity we don't know. We are not given any information about it, so we can't write what that is. Acceleration was 1.09 meters per second squared. And let's put the units there as well. Then the time taken. This is what we are trying to find. So now we need to decide which equation we should use. Since we don't know V, we should not pick one which involves V. And we are trying to find T, so our equation needs to have T involved. S equals ut plus half at squared would be the correct one because it does not have V and it has the T that we require. Putting these values in, we will have 1.4 equal to U is 0 plus a half times 1.09 times T squared. Rearranging this equation, we can first multiply by 2 and that will give us 2.8 equal to 1.09 T squared. Then dividing by 1.09, we will get T squared equal to 2.8 over 1.09, and we can take the square root of both sides. We are now asked to calculate the velocity of mass B after falling down 1.4 meters. This question is very similar to the previous one, and we need to use another suvat equation. The values for the variables will not be different from the previous one because the mass is falling 1.4 meters. That's giving the displacement as 1.4. Initially it was at rest, so U is 0. The acceleration is the same as before, which is 1.09, and we are interested in finding the velocity. The time it takes to go down 1.4 meters is the answer to the previous part, which was 1.6 seconds. Now we need to pick an equation which will give us the velocity, and we can use v equals u plus at. That gives us, with u being 0, 1.09 times 1.6, so the velocity will be 1.74 meters per second.